Hi, my name is Kate Berry from the University of Texas at Austin, and today I'm going to be talking to you about Equation Quest. Equation Quest is the second activity in our individual intervention with total difference and change schemas, and the second activity in our small group intervention with total difference, change, and equal group schemas. Both our individual intervention and small group intervention have 5 different activities. The first is Math Fact flashcards, followed by Equation Quest, Buccaneer problems, ship shape sorting, and our Jolly Roger review. The focus of today's lesson or today's video is going to be Equation Quest, which is again the second part of the intervention. Equation Quest is a 3 to 5 minute activity that immediately follows Math Fact flashcards. And in Equation Quest, we really focus on developing students' pre-algebraic reasoning skills. And what that means is that we teach students to develop an understanding of the equal sign. We want students to understand that the equal sign does not solely symbol a calculation, but that the equal sign means that what's on one side is the same as what's on the other side. We want students to understand that there's a balance between two sides of the equation. So in Equation Quest, students set up and solve standard and non-standard equations. Some of these activities include using a picture of a balance. In other activities, students draw shapes to show that two sides are balanced. And in other activities, students use cubes to show that two sides of the equation are balanced. We really believe that it's important for us to focus on Equation Quest and pre-algebraic reasoning skills because it fills the gap between arithmetic and algebra. And in our program, when students understood that the equal sign meant balance and that what's on one side of the equal sign means what's on the same as the other, they were more equipped to set up and solve equations, and in turn they were better prepared to solve word problems. In fact, in our research, students who received Equation Quest in the intervention demonstrated improved word problem performance over students who did not receive Equation Quest. So we really are focusing on pre-algebraic reasoning skills, and I'm going to model several of the activities that we present to students during Equation Quest in this presentation. So when we do Equation Quest, students need the following activity materials. They always need their Equation Quest worksheet, which looks like this. Also, students will need a pencil. And at the bottom of the worksheet here, we see that there's a picture of a balance. Here we see the equal sign, and here we see what's the left side of the balance and the right side of the balance. We also see cubes up here. Some activities involve students using cubes. Other activities involve students using the pencil. Importantly, we are really focused on multiple representations here. So we are using concrete 3D manipulatives, such as the cubes, and we're also using pictorial representations when students draw by using the pencil. So students always need their pencil and they always need the worksheet, but sometimes they need the cubes and sometimes they don't. During Equation Quest, students follow a set of scaffolded activities. Specifically, students first learn that the equal sign is a relational symbol, meaning that the equal sign acts as a balance, that what's on one side of the equal sign is the same as what's on the other side of the equal sign, and that the equal sign does not solely signal a calculation. After students develop an understanding of the equal sign as a relational symbol, students set up and solve standard equations. And standard equations are equations where the operator symbol, or the plus sign, minus sign, etc., are on the left side of the equal sign. After students have learned to set up and solve standard equations, students learn to set up and solve non-standard equations. And in non-standard equations, the operator symbol, the plus sign, the minus sign, etc., is either on both sides of the equal sign, on the right side of the equal sign, or there's no operator symbol in the case of identity statements. After students learn to set up and solve non-standard equations, we teach students to isolate the x. And isolating the x is just a fancy way of saying to get the x alone on one side of the equal sign. As we go through this presentation, I'm going to model different activities within these 4 different areas. What's important to note here is that these activities are scaffolded and that they build on one another. And in terms of complexity, they start with the least complex, and then with isolating the x, they become more complex. So the first activity, the equal sign as a relational symbol. Here, when students learn that the equal sign is a relational symbol, we're really introducing them to pre-algebraic reasoning skills. So here we want students to understand that the equal sign means the same as. So when we start talking about the equal sign as a relational symbol, we ask students to replace the words equal sign with the same as. So on all of our worksheets, you'll see this definition at the top to prompt students that instead of saying the equal sign, we're saying the same as. So in an introductory activity, students might be presented with these equations. And the teacher or tutor would ask the students to replace equal sign with the same as. So for example, in our first instance here, where it says 5 plus 8 equals 13, the teacher would prompt students to say 5 plus 8 is the same as 13. Again, students would say 5 plus 8 is the same as 13. With the second example down here, 5 equals 2 plus 3, students would then practice saying 5 is the same as 2 plus 3. Again, 5 is the same as 2 plus 3. It doesn't matter where the equal sign is in the equation, we just teach students to say the same as. So these are activities that fall in our first category, or understanding the equal sign as a relational symbol. After students understand the equal sign as a relational symbol, we teach students to set up and solve standard equations. So what am I talking about when I talk about standard equations? Standard equations are equations where the operator symbol is on the left side of the equal sign. And let me show you some examples. Here, 5 plus 8 is the same as 13. Our operator symbol in this example is a plus sign, and we see it falls on the left side of the equal sign. In our second example, 3 plus 4 is the same as blank. Here's another example where the operator symbol is a plus sign, and it falls on the left side of the equal sign. With our examples over here, our operator symbol is a minus sign, but these are still standard equations because the minus sign falls on the left side of the equal sign. Here, blank minus 1 is the same as 6. We see that the minus is on the left side of the equal sign. In this final example, 14 minus blank is the same as 9. Again, we see the operator symbol falling on the left side of the equal sign. Another way to think about this is that the equal sign or same as sign is the second to last thing you see. So it's right before our difference here, and it's right before our sum over here. So students first learn to set up and solve standard equations where the operator symbol is on the left side of the equal sign. So let's take a look at some examples here. Again, during Equation Quest, we're teaching students to use multiple representations. So we teach students to use concrete 3D manipulatives like cubes, and we also have students to use pictorial representations by drawing. In this example, I see cubes, which is an indication to me that the students are going to use cubes or the 3D concrete representations to solve this problem. I'm going to model how to solve this problem, and in doing so, I'm going to walk on over to our DocCam where I have my cubes in this problem waiting for me. So here our example is 1 plus 6 is the same as blank. Notice at the top it says equal sign means the same as. That's because we want students to replace saying equal sign with the same as. So our problem is 1 plus 6 is the same as blank. Here I have a picture of my balance. What's on the left side of the equal sign corresponds with what's in this box, and what's on the right side of the equal sign corresponds in this box. I'm going to use my cubes to help me solve this problem. I have 1, so I'm going to place 1 cube in the box. I also have 6, so I'm going to place 6 cubes in the box. 1, 2, 3, 4, 5, 6. Now I need to ask myself, are the sides the same? Are there the same number of cubes in this box as in this box? And my answer is no. Because we're adding, I need to ask myself, what can I add to this box to make it the same as this box? And I see that if I add the same number of cubes to this box as there are in this box, then my equation will be balanced. So I'm going to add cubes to this box. And now I see that my equation is balanced. They're the same number of cubes on the left side of the equal sign as there are on the right side. So what I need to do now is count the cubes. 1, 2, 3, 4, 5, 6, 7. So I'm going to write 7 as my answer. So my completed answer, my completed equation is 1 plus 6 is the same as 7. Now that we've solved 1 plus 6 is the same as 7, let's solve another standard equation. But this time let's solve the standard equation using pictures or drawing. Here I see that this is a standard equation and it's subtraction because I see the minus sign. Our equation reads 9 minus blank is the same as 3. Again, over here I see a picture of my balance. What's on this side of the equal sign corresponds to this box, and what's on this side of the equal sign corresponds to this box. So here I see that I have 9. So what I'm going to do is I'm going to draw 9 circles in this box to represent the 9. I have 9 circles in this box. Then on the right side of the equal sign I see a 3. So I'm going to draw 3 triangles on this box. Let's fix these. So that they are better in our box. So I have 9 on this side and I have 3 on this side. Now I see the minus sign and that's going to tell me to subtract. So what I need to ask myself are the sides the same? Are there the same number of shapes in this box as in this box? There are not. So I know I need to subtract because I see the minus sign. So I'm going to subtract or cross out these circles until I have the same number of circles as I do triangles. So now I have 3 circles and 3 triangles. My sides are the same. So I subtracted 6. Because I subtracted 6, that's going to be the number that goes here. So I know that my equation completed reads 9 minus 6 is the same as 3. So after students develop an understanding that the equal sign means the same as, and they understand the equal sign is a relational symbol and not simply as a symbol signaling a calculation, then we teach them to set up and solve standard equations like the 2 I modeled with the cubes and with the shapes. Next, students learn to set up and solve non-standard equations. Non-standard equations are equations where the operator symbol falls on the right side of the equal sign, on both sides of the equal sign, or no sides of the equal sign because there is no operator symbol, such as in an identity statement. Let me show you some examples of some non-standard equations that students might encounter during Equation Quest. 13 is the same as 5 plus 8. 12 is the same as 12. 10 is the same as 16 minus blank. And 14 minus blank is the same as 9 minus 4. In this first example, 13 is the same as 5 plus 8. This is a non-standard equation because the operator symbol, the plus sign, falls on the right side of the equal sign. Our second example here, we don't have an operator symbol. 12 is the same as 12 is an identity statement, and identity statements are examples of non-standard equations. When we looked at our third example, 10 is the same as 16 minus blank, we see our operator symbol, the minus sign, again is falling on the right side of the equal sign, which tells me it is a non-standard equation. Lastly, we see here 14 minus blank is the same as 9 minus 4. We have 2 operator symbols. We see a minus sign on the left side of the equal sign, and we see a minus sign on the right side of the equal sign. This tells me that this is a non-standard equation. So after students learn to set up and solve standard equations, then they learn to set up and solve non-standard equations, where the operator symbol is non-existent, falls on the right side of the equal sign, or falls on both sides of the equal sign. So now let's look at some examples of non-standard equations that students might solve during Equation Quest. So here I see the pencil, and that's going to tell me that I'm going to draw to solve this problem. Again, we're using pictorial representations and concrete representations with our cubes to help students understand these concepts related to pre-algebraic reasoning. So here this problem says 6 is the same as blank plus 2. Again, what's on the left side of the equal sign up here corresponds to this box here. What's on the right side of the equal sign over here corresponds to this box here. So I have 6 on the left side of the equal sign. So let's draw 6 circles. 1, 2, 3, 4, 5, 6. 6 circles on the left side. On the right side of the equal sign, I see a 2. So let's draw 2 triangles over here. Now I need to ask myself, are the sides the same? I have 6 over here and 2 over here. The sides are not the same. And I know this problem is an addition problem because I see the plus sign. That means I need to add shapes to this side of the equal sign to make this side the same as this side. So what I'm going to do is I'm going to go ahead and add, let's do squares until the sides are the same. Now I need to ask myself, are the sides the same? Yes. I have 6 shapes over here and 6 shapes over here. The sides are balanced. So how many did I add to this side to make it the same as this side? If I look here, I can see that I added 4 squares. So I know that 4 is going to be my answer. When I read my completed non-standard equation, it says 6 is the same as 4 plus 2. Now let's walk over to the doc cam and look at an example using cubes. When we look at this example, again we see it says equal sign means the same as. That's to prompt students to say the same as instead of equal. So let's look at our non-standard equation. This says 5 is the same as 8 minus blank. I'm going to use cubes to solve this problem. What's on the left side of the equal sign corresponds to this box, and what's on the right side of the equal sign corresponds to this box. So I'm going to go ahead and put 5 cubes on the left side. 1, 2, 3, 4, 5. Now I need to look at the right side. I see an 8, so I'm going to put 8 cubes on this side. 1, 2, 3, 4, 5, 6, 7, 8. And we like to use different colored cubes so that it's easier for students to visualize. Here I need to ask myself, are the sides the same? When I look, I see there are 5 on this side and 8 on this side. The sides are not balanced. So I need to ask myself, what do I need to do to make the sides the same? I see a minus sign here, which tells me that I'm going to subtract from this side until the right side of the equal sign is the same as the left side. So let's go ahead and subtract. Now I see their sides are the same. There are 5 cubes on the left side and 5 cubes on the right side. And I can look here and see that I subtracted 3 cubes to make the sides the same. So I'm going to write 3 as my answer. When I read my completed non-standard equation, it says 5 is the same as 8 minus 3. Now that we've solved 2 non-standard equations, let's take a look at isolating the x. Again, these activities are scaffolded, so students develop an understanding of the equal sign as a relational symbol. They learn to set up and solve standard equations. Then they learn to set up and solve non-standard equations. Then they learn to isolate the x. Isolating the x is a fancy way of saying we want to get the x alone on one side of the equal sign. I'm going to show you in more detail what I mean on the following slides. So now let's take a look at some example equations that students might see when isolating the x. I'm going to show all of them here now, and then in the following slides, I'm going to actually demonstrate how to isolate the x in each of the examples. Here, students first might see 8 plus 3 is the same as x. Here, the x is already isolated or alone on this side of the equal sign. Students also might isolate the x in this standard equation. X plus 4 is the same as 11. Here the students need to subtract 4 from both sides to isolate the x. Students also learn to isolate the x in equations with a minus sign. Here x minus 6 is the same as 3. Students have to add 6 to both sides to isolate the x. Students also learn to isolate the x in problems like this. 7 minus x is the same as 5. Here, students actually need to move the x to the other side of the equal sign in order to isolate it. And we'll talk about that in more detail in the slides that follow. Students also learn to isolate the x in equations like this non-standard equation that reads 9 minus 4 is the same as x minus 1. Here, students have to simplify the left side of the equation before they isolate the x. In our small group intervention, students learn the equal groups schema, and the equal groups is our multiplicative schema. So in the small group intervention, students also learn to isolate the x in multiplicative problems such as the one here. This says 2 times 10 is the same as x. Here the x already is isolated. Also in our small group intervention, students learn to isolate the x in problems that look like this. X times 5 is the same as 25. And in this problem, the students have to divide 5 from both sides in order to isolate the x. Again, in the slides that follow, we will look specifically at these examples, and I will show you and demonstrate how to isolate the x. So what really am I talking about when I'm talking about isolating the x? Again, I'm talking about getting the x alone on one side of the equal sign. So in this picture, you can see here that the x is mixed with all these other numbers. And here, the x is alone on this side of the equal sign. Here, the x is isolated. This is what we're teaching students to do. Isolating the x follows the same 4 general steps, regardless of whether it's a standard equation or a non-standard equation. First, we ask students every time, what does it mean to isolate the x? We want students to be able to say it means to get the x alone on one side of the equal sign. The second step is to draw a line down from the equal sign, and this reminds students again to balance both sides of the equation. The third step is that we ask students to circle the x. This reminds students that we need to see the x so we can figure out what we need to do. Lastly, students actually isolate the x. So students determine if the x already is isolated or whether or not they need to add, subtract, divide to isolate the x. So those are the 4 main steps that you'll see in the next slides. So let's take a look at our first example. This example says 8 plus 3 is the same as x. So to isolate the x, I ask students, what does it mean to isolate the x? And they say, Miss Kate, it means to get the x alone on one side of the equal sign. The next thing we're going to do is draw a line down from our equal sign. This reminds students to balance both the sides. Then we're going to circle the x. We circle the x so that we can see him. And we say, is x alone on this side of the equal sign? Well, he is. He's alone on this side of the equal sign, so we know we can just add these 2 numbers. 8 plus 3 is the same as 11. So I'm going to write x is the same as 11. We start off with examples where the x is already isolated and then build up. Let me show you in the next example. So here's an example of student solving or isolating the x in an equation where the x is already isolated. We see here the student drew the line down in between the equal sign, or from the equal sign, the student circled the x. The student determined that x already was isolated, and so the student knew that he or she could subtract 75 minus 63, which was 12. And then the student wrote x is the same as 12. So let's look at our second example. This standard equation says x plus 4 is the same as 11. My first step always is to ask students, what does it mean to isolate the x? It means to get the x alone on one side of the equal sign. Our second step is to draw a line down from the equal sign to remind us to balance both the sides. Now that we've done that, I'm going to circle the x. This helps me figure out if x is isolated or if we need to isolate the x. Here when I look, I see that x is not alone on this side of the equal sign. There's a 4 next to the x. So to isolate the x, I need to get rid of the 4. If I have a plus 4, to get rid of that, all I need to do is do the opposite. So if I have a plus 4, I can put a minus 4. And that cancels out to be 0, so I can cross that whole thing out. But what I do to one side of the equal sign, I have to do the same thing to the other side of the equal sign. So on the left side of the equal sign, I subtracted 4, so I need to do the exact same thing on the right side of the equal sign. 11 minus 4 is, my 4 is a little messed up here. 11 minus 4 is 7. Here, all this is crossed out. It's isolated. X is the same as 7. So when I read my completed number sentence now, it's 7 plus 4 is the same as 11. So here's an example where the student had to subtract to isolate the x, just as in the example I demonstrated. Here it says x plus 3 is the same as 18. We see that the student drew the line down from the equal sign, circled the x. The student determined that the x was not isolated. It said plus 3, so the student did the opposite, minus 3, put a 0, crossed it all out. But if the student did minus 3 on this side, the student knew he or she had to do minus 3 on this side. And 18 minus 3 is 15. So x is the same as 15. Just another example of student work. So let's look at our third example. This example says x minus 6 is the same as 3. So again, my first step is to ask students, what does it mean to isolate the x? Miss Kate, it means to get the x alone on one side of the equal sign. Nice job. Our second step is to draw a line down from the equal sign to remind us to balance both of the sides. Our third step is to circle the x so that we can see it. We need to ask ourselves, is x isolated? No, x is not alone on this side of the equal sign. The 6 is next to the x. So to isolate the x, we need to move the 6. If it says minus 6, all we need to do to cross this out is to do the opposite of minus 6, which is plus 6. Minus 6 and plus 6 are going to give us 0. So I can cross that whole thing out. But what I do to one side of the equal sign, I have to do to the other side. If I plus 6 or add 6, I have to add 6 to this side as well. 3 plus 6 is the same as 9. X is the same as 9. When I read my completed number sentence or my completed standard equation, it reads 9 minus 6 is the same as 3. So here's an example of when students had to add to isolate the x, and we'll see an example of student work on the next slide. So here's an example of student work where we have a standard equation where the student had to add to isolate the x. The student forgot to draw a line down from the equal sign, but the student did circle the x. The student noticed that the x was not alone. To get the x isolated, if it says minus 33, we have to do the opposite, so we did plus 33. The student crossed that out. If the student did plus 33 to this side, the student needed to do plus 33 to this side. The student added these two numbers for a correct answer of 89. X is the same as 89. Let's take a look at our next example. So this example is 7 minus x is the same as 5. Here, we first ask students, what does it mean to isolate the x? And the students say, it means to get the x alone on one side of the equal sign. Our second step always is to draw a line down from the equal sign. This reminds us to balance both of the sides. Then we're going to circle the x so that we can see the x. Now we need to ask, is the x isolated? Is it alone on this side of the equal sign? The x is not alone on this side of the equal sign. We also see a minus in front of the x. We teach students that whenever we see a minus in front of the x, we have to cross it out and put a plus x on the other side of the equal sign. We teach students that whenever there's a minus in front of the x, again, we cross it out. That we teach students that the x does not like a minus in front of it. We move the x to the other side of the equal sign, and then we're ready to set up our problem again. So here, our new setup is 7 is the same as 5 plus x. I'm also going to draw the line down from the equal sign again. I'm going to circle my x. Then I'm going to ask myself, is x alone on this side of the equal sign? The x is not alone on this side of the equal sign. There is a plus 5 next to the x. So to get the x alone, or to isolate the x, I need to do the opposite of plus 5, which is minus 5. A plus 5 and a minus 5 is going to give me 0. But what I do to one side of the equal sign, I also have to do to the other side. If I minus 5 over there, I also have to minus 5 over here. 7 minus 5 is the same as 2. So x is the same as 2. So when we read our completed standard equation, it should say 7 minus 2 is the same as 5. Again, whenever we have an example where there's a minus x, we teach students to cross it out and to move the x to the other side of the equation, or the other side of the equal sign, and to put a plus in front of it. Now let's take a look at some student work where this student solved a problem similar to this one. So let's take a look at an example of student work where the student solved a problem where there was a minus in front of the x. This problem says 100 minus x is the same as 50. We see here that the student drew a line down from the equal sign as a reminder to balance both the sides. The student circled the x. The student noticed there was a minus in front of the x, so the student crossed this out and wrote plus x on the other side of the equal sign. The student realized that the x was not isolated, and to isolate the x, the student knew that he or she had to subtract 50 because there was a plus 50 here. If we subtract 50 from this side, we also have to subtract 50 from this side, and 100 minus 50 is 50, so x is the same as 50. The student did an excellent job solving this problem. So now let's take a look at an example where there is an operator symbol on both sides of the equal sign, and we ask students to isolate the x. This problem says 9 minus 4 is the same as x minus 1. First, we ask students, what does it mean to isolate the x? They say to isolate the x means to get the x alone or by itself on one side of the equal sign. Next, students draw a line down from the equal sign as a reminder to balance the two sides. The next thing we do is we have students circle the equal sign so that we can see it. Or circle the x, excuse me, so we can see it. So let's circle the x. Whenever we have operator symbols on both sides, we have a minus sign over here and a minus sign over here, we teach students to take a look and see if there's anything that they can add or subtract before we isolate the x. So first, let's cover up the right side of the equal sign. Here we see 9 minus 4. We know we can go ahead and subtract. 9 minus 4 is the same as 5, so I'm going to do that. Then I'm going to cover up this side of the equal sign. This says x minus 1. There isn't anything I can do ahead of time there. But I am going to rewrite my equation. This says 5 is the same as x minus 1. So just to back up for a second, whenever there are operator symbols on both sides of the equal sign, we want to ask students if there's anything we can add or subtract ahead of time before we isolate the x. And we do that first by covering up the right side of the equal sign and then by covering up the left side of the equal sign. Now we have our new equation. 5 is the same as x minus 1. So I'm going to draw a line down again from the equal sign, and I'm going to circle my x. Now we need to ask ourselves, is x isolated? Here I see that the x is not isolated. There's a minus 1 next to the x. To get rid of the minus 1, I'm going to simply do the opposite, which is plus 1. Minus 1 and plus 1 gives me 0, so I can cross that out. But whatever I do to one side of the equal sign, I need to do to the other. If I did a plus 1 on this side, I need to add 1 on this side also. 5 plus 1 is the same as 6. So x is the same as 6. So let's read our completed equation. 9 minus 4 is the same as 6 minus 1. Now let's take a look at student work where there were two operator symbols and the student isolated the x. Here is an example of a non-standard equation where the student had to simplify a side before isolating the x. This equation reads x minus 16 is the same as 20 plus 35. Here we see the student drew the line down from the equal sign and circled the x. So we crossed out or covered up this side of the equal sign. There's nothing we could do ahead of time. The student, let me go over here. If we cover up this side of the equal sign, we see that we can go ahead and add 20 plus 35. The student did that. 20 plus 35 is the same as 55. Then the student rewrote the equation. X minus 16 is the same as 55. The student drew the line down from the equal sign. Again, circle the x. Isolated the x. If it said minus 16, the student did plus 16 to get 0. The student added 16 to this side. The student knew he or she needed to add 16 to this side. So our answer here is 71. In our small group intervention, students learn to solve equal groups schema or multiplicative problems. So in our small group intervention, students learn to isolate the x with multiplying and dividing. So here's one example that the students might be presented with during equation quests in our small group intervention. This problem says 2 times 10 is the same as x. Just like our other problems, we first need to ask, what does it mean to isolate the x? To isolate the x means to get the x alone on one side of the equal sign. Second, we draw a line down from our equal sign as a reminder to balance both of the sides. Next, we're going to circle the x so that we can see it. Here, we've circled the x. Now we need to ask ourselves, is the x already isolated or do we need to isolate it? In this problem, we see that the x already is isolated and alone on this side of the equal sign, so we can simply multiply these two numbers. 2 times 10 is the same as 20, so x is the same as 20. And when I read my completed equation, it reads 2 times 10 is the same as 20. Here's an example of student work when students using the equal group schemas to isolate the x. Here we have GR, or the number of groups, times the number in each group is the same as the product. If you want more information on the equal group schema, we have a PowerPoint presentation dedicated to that, so please view that if you're interested. Here, we see that the student drew a line down from the equal sign and circled the x. The student determined that x already was isolated, so the student multiplied 5 times 3. 5 times 3 is the same as 15. The student put a number label and a word label as an answer. So let's take a look at our final example. In our small group intervention, when students learn the equal group schemas, they also isolate the x in problems that look like this. This problem says x times 5 is the same as 25. First, we ask students, what does it mean to isolate the x? To isolate the x means to get the x by itself or alone on one side of the equal sign. Next, we're going to draw a line down from the equal sign as a reminder to balance both of the sides. Third, we're going to circle the x so we can see it and determine if it's isolated or if we need to isolate it. Let's go ahead and circle that x. Here, when I look, I see that there's a times 5 next to the x. The x is not isolated. To get the x by itself, I need to do the opposite of times 5. The opposite of times 5 is divided by 5, which is going to give me 1. Any number times 1 is that number, so really this is just going to be x. If I divided 5 on this side, I have to divide 5 on the other side, because what I do to one side of the equal sign, I have to do the exact same thing to the other side. Here, I knew that to isolate this x, I needed to do the opposite of times, or opposite of multiplication, which is division. Times 5 and divided by 5 is going to give me 1. Any number times 1 is that number, which is why I put the x right here. So if I divide by 5 on this side, I have to do the exact same thing on this side. 25 divided by 5 is going to give me 5. Now, if your students are still working on their division fluency, we can also ask what times 5 gives us 25. And that might be an easier way for students to come to this answer. In any case, our answer is 5. X is the same as 5 is our completed answer. So when we read our completed equation, it should say 5 times 5 is the same as 25. Now let's take a look at an example of student work that's similar to this problem. So here we see an example of student work where the student had to divide in order to isolate the x. This is an example of a problem that was in our small group intervention where students were learning the equal group schemas. Again, if you want more information on our equal groups schema, you can view that PowerPoint presentation. But let's take a look at this example of student work. Here we see the student drew a line down from the equal sign as a reminder to balance both of the sides. The student circled the x. The student determined that the x was not isolated. It said times 4 or multiplied by 4, so the student knew he or she had to divide 4 because times or multiplication and division are opposites. So 4 divided by 4 gives us 1. If we divide by 4, we have 1. 1 times x is going to give us x because any number times 1 gives us that number. If we divide by 4 on this side, we have to divide by 4 on this side. 20 divided by 4 is 5. Our answer is 5 flowers. If students, again, are working on their division fluency, you can say 4 times what gives us 20. So now that we've talked about Equation Quest, we've reviewed understanding the equal sign as a relational symbol, setting up and solving standard equations, setting up and solving non-standard equations, and isolating the x. We're going to look at an example of a teacher working with a student during the Equation Quest activity. Now, as you view this activity, I want you to think about a couple of things. Number one, the student is reading the equation aloud. The student is replacing equals with the same as. The student also is drawing a line down from the equal sign as a reminder to isolate the x and to balance both of the sides. The student circles the x so that they can see so that she can see the x. Also, in this example, we have a minus x, so the student is moving the x to the other side of the equal sign in order to solve it. It's important to note as you view this video that during our intervention, we found that students had lots of difficulty when there was a minus x and the student needed to move the x to the other side of the equal sign. So we created a fun little story telling students that if there's a minus in front of the x and the x was so mad that the x had to leave the room and go to the other side of the equal sign. So in this video, you'll hear some of that language, and that's what that's about. If there's a minus in front of the x, we said that the x was angry, the x had to leave the room and move to the other side of the equal sign. So as you view this video and you hear that language, that's what we're talking about. Thank you so much for taking the time to watch this video.
All right, Mia, got your pencil? Ready? All right, let's look at our equation quest for today. What does the equal sign mean? What? What is it? You're right, the equal sign means the same as. Look at number sentence A. Can you read it for me?
19 minus x is the same as 15.
Nice job. Whenever you see the equal sign like this, what do you do?
Draw a line.
Go for it. What's the line remind you?
To balance.
Show me with your hands. Balance. Yeah, good. Is there anything on the left-hand side you can add or subtract?
No.
What about the right?
No.
No? What are you going to do? Well, we could run, but what can we do to the x?
Isolate.
Yeah, let's isolate him. What's it mean to isolate him?
Get rid of him.
Well, not get rid of him, but get rid of the people next to him, right? We want to get him all by him. Yeah, get him all by himself. What can we do to make it so that we see him better?
Circle.
Yeah. You got this. Now what? What do you see that's special about this x? Oh, yeah. Why'd you do that?
Because it's a minus.
Yeah, and whenever there's a minus sign in front of x, what do we have to do?
Cross them out.
Yeah, we cross him out and we take him to the other side. He has to leave the room because he's so angry, right?
Mm-hmm.
Yeah, now what? Good. Why'd you do minus 15? Because it's what? Would it make sense if we did 15 plus 15? No, our number would get bigger. And what are we trying to do to x?
Isolate.
Yeah, we want to isolate him. We want to get him all by himself. Nice job. What math symbol should we put next to our 15? I know this plus was from earlier. What should we have? Can you tell me?
Minus.
Yeah, why does it have to be a minus?
Because you have to balance
Yeah, you have to balance. Whatever you do on this side of the equal sign, you also have to do...
the other side.
Exactly, you're crushing it. I like it. Keep going. Nice work. Can you read the new number sentence to me?
19 minus 4 is the same as 15.
Amazing job.
Thank you so much for viewing this video focused on equation quests in our individual intervention and our small group intervention. We would like to take this opportunity to thank IES, the University of Texas at Austin, and the Meadows Center for their help with this video. Without their support, this work would not be possible. Thank you so much for watching.